My screen is visible to all?
Yes, yes, yes.
Okay. Okay. So, I am Dr. Anupama, Associate Professor, Galgotia University, Greater Noida. First of all, I want to convey my heartfelt gratitude to the Honorable Director Sir, HOD Sir, and the organizing committee of BIT SINDRI for giving me this golden opportunity. I'll give my best to fulfill the requirement and standard of this program. Through my lectures, I will try to give some input about advanced optimization technique, especially on genetic algorithm, which has vital role in design, robotics, communication network, etc. So, these are the contents I will cover through my presentation. In first half, I'll give you some overlook on optimization, their types, parameter, techniques, and after that, I'll discuss about one of the most important and popular advanced optimization technique,
Madam,
genetic algorithm. Yes?
madam,
Yes?
your slide is not scrolling.
My voice is tracking.
Your slide.
My slide is, I'm in
Not
content.
scrolling. Yeah. Not scrolling, means it's not going to next slide.
Okay. It is not visible. Second slide is not visible to you.
No.
Actually, it is there. You have to scroll to your first slide. It's just the introduction.
I'm doing so, but I don't know why it is so. My slide of the content is not visible to you.
Yeah, it is not visible actually.
Okay.
Yeah.
Yeah, it's okay. It's okay.
I think it is presentation mode. It is not visible.
No, it is okay.
Now it is
It's on
visible.
the- Yeah.
Okay. Okay. Thank you. Okay. So, what is optimization? Optimization is derived from Latin word that is optimus. It means the best. Different researchers and mathematicians have given different definitions for the optimizations. Some has defined it as an important tool in making decisions and in analyzing physical systems. It is to make perfect or characterize the activities involved to find the best. Some have defined it as a choosing the best element from some set of the available alternatives. Some have defined it as a mathematical discipline. It is considered as a mathematical discipline also in some of the organizations. There is a separate department also in IIT Madras for the optimizations. So this is also taken as a mathematical discipline nowadays, which is concerned with finding the maxima, minima of the functions possible subjects to constants. It is also considered as an art, process or methodology of making something, a design, system or decision, as perfect, as functional, as effective as possible. It is to find the value of the variables in the process that is the best value of the performance. So here we have seen the different examples in how many ways we can understand that what is optimization. Optimization is basically the process of choosing, selecting the input. Our input should be in such a way that if we process from that input, we will get the best output. So basically, here in the diagram also it is showing that We have to select the set of inputs in such a way that our output is best. So this is the optimization, the process of making something better. Here we have, I have shown you that the optimization is such as manufacturing, productions, inventory control, transportation, scheduling, networks, finance, engineering, mechanics, economics, control engineering, marketing, policy modeling. There are so many fields are there where we can use the optimizations. Optimizations is necessary because it increases the productivity, it reduces the cost, it reduces the error, reduces the time, it is helpful in better designing. So it is also used in network routing. Network routing, how it is network routing is a process of selecting routing path in a communication network can be optimized to lower cost, improve network utilization and maximize the performance. Optimization may include here like cost, bandwidth, service, label agreements, number of hops, availability, etc. So this is the reason why optimization is necessary and what we can do from optimizations. So according to the problem, we choose the optimization technique because there are so many techniques available. If you want to design something, you have to use the different optimization. Later on, I'll discuss that also. That among so many optimizations techniques, which techniques we have to use where? Where we have to use this optimization, what the optimization technique we will use for designing, for increasing the productivity, for saving the time, for reducing the errors, or for the you can say communication network. In broad sense, if we talk about the optimizations, basically in mechanical department, so design is the major component, major field you can say where we can use and where it is using, we are using optimizations in many ways for reducing the weight of a component, for designing the mechanical component, you can say mechanical equipments, optimal trajectory we can find for space missions. The trajectory we used to find the path trajectory for the robotics also using the optimizations. Minimum weight design of the structures, optimal designs of electric networks, optimal productions planning, resources allocations, scheduling. We can also use it in to find the shortest route. Design of the optimum pipeline networks, minimum processing time in production systems. So, in broad sense, we can use the optimizations in these ways. It is also known as a mathematical programming because this is the collections of mathematical principles. We will use the mathematical rules under some constraints. We have to design the problems according to the problems given to you. So first of all, we model the mathematical programming according to the problem, and then we see the nature of the problem, and then we apply the techniques. So that is why it is also known as a mathematical programming. That is collection of mathematical principles, you can say. A method used for solving quantitative problems in many disciplines including physics, biology, engineering, economics and business. Here we will discuss some types of optimizations. First is constant optimizations. Constant optimizations means we have to optimize the system, optimize the problems by satisfying some constants. Or we have some constants, we have some restrictions of resources, and under that circumstances, under that conditions, we need to optimize the system. It means we have some restrictions and still we need to optimize the problem. So constant optimization is that we cannot take all the values. We have to satisfy. Here the decision variables we are taking for optimizing the problem. It should satisfy the constants. So what is constant optimization? Finding out the best value of certain variable, optimizing in presence of some restrictions, set constraints like maximizing its productions with available resources or minimum time to sell more. So this is the constant optimizations. Unconstant optimizations, it means we whole world is our from the whole world we can take the input. There is no restrictions. We don't have the limited resources. We can take the input from the whole world. The whole entire world is our domain. No constant is there. No restriction is there. So this is unconstrained optimization. Problems consider the problem under this optimizations is for minimizing the objective functions or maximizing the objective functions. Depends upon the real values, no restrictions of their values. If you take the decision variable, there will be no restrictions. So basically, we can say optimization is divided into two main parts, that is constant and unconstant. Constant optimizations having the restrictions of the resources, restrictions of the decisions variables we are taking, okay, and in unconstant optimizations there is no restrictions. Just we have to focus on the optimization of the problem. We have to optimize the problem. So this is the most important optimization, that is constant and unconstant optimization. The second one is robust optimization. Robust optimization is an emerging area in research that allows addressing different optimization problems and especially industrial optimization problems, where there is a degree of uncertainty in some of the variables involved. Here we have here the condition is that the data involved data is uncertain. It may change any time, and under this condition we need to optimize the system. So these with the optimization problem in which a certain measure of robustness is sought against uncertainty that can be represented as deterministic variability in the value of the parameters of the problem itself and or its solution. Used when the parameters are known only within the certain bounds, and the goal is to find a solution that is feasible for all data and optimal in all sense. So there are two approaches to deal with the data uncertainty in optimization. Namely, one is robust and another is stochastic optimization. Later on we will see the stochastic optimization also. So in optimizations, uncertainty data handled with the robust and the stochastic optimizations. In a simple language, if I want to define robust optimization, it is subfield of optimization, and the goal is to make a decision that is feasible no matter what the constraint turn out to be, and optimal for the worst case objective function also. So this is robust optimization. I hope it is clear to you. Now the third one is continuous optimization. Means finding the minimum or maximum value of a function of one or many real variables. Subject to constants, the constant usually takes the form of equations or inequalities. So continuous optimizations where we have a flow of the decision variables will be a real variable. There is a discrete optimizations also. Continuous and discrete are not disjoint. In fact, they are closely related, and techniques from one area are used in a second one also. So, discrete optimization means searching for the optimal solution in a finite or countably infinite set of potential solutions. Optimality is obtained with respect to some criterion functions, which is to be minimized or maximized by generating a sequence of continuous subproblems. So these two are not different. Discrete and continuous both are related to each other. Continuous optimization, that it means there is a continuous flow of the real variables, and the discrete optimization, that it is defined in a certain bounds. So models with discrete variable are discrete optimization problems, and models with continuous variable are continuous optimization problems. Deterministic optimization problem, where the data is certain, accurate. There is no uncertainty is there. So, deterministic optimization is assumed that the data for the given problem are known accurately. However, for many actual problems, the data cannot be known accurately for a variety of reasons. The first reason is due to the simple measurement error. The second and more fundamental reason is that some data represent information about the future, and sometimes we cannot have the exact data also. So, in example, you can say product demand or price of a future time period, and simply cannot be known with the certainty. So, deterministic optimizations works with where the data is fixed. Data is sure and short, it's not going to change. And for that type of data, we use deterministic optimization. Stochastic optimization, the uncertainty is incorporated into the model and take advantages of the fact that the probability distribution governing the data are known or can be estimated. The goal is to find some policy that is feasible for all the possible data instances and optimize the expected performance of the model. So this is the broad sense where we take the advantages of the fact that we are using the probability distribution. We use the probability distribution to get the correct data for the estimation. Dynamic optimizations, where the data may change according to the time. Over the time, the dynamic data may change. Here, see, you can see the deterministic, where the data will remain same. Data is first we collect the data which is not going to change. Stochastic, where data can change, but we used to make it certain by using some probability distribution. It is the way of modeling uncertainty using where the exact data is unavailable or expensive, or data is uncertain specified by a probability distribution. If we want to make the best decision given this uncertainty in the data. Stochastic optimization is very important for the logistic, transportation model, financial instruments, network designs, production planning. So this also we can say that has a vital role in optimization. Dynamic optimization is very simple as where value changes over time, where data may change over the time, where the data depends upon the time. That type of optimization comes under the dynamic optimization. Here we used to break down the problems into some small parts. First is, it means a big problem can be simplified by splitting it into a number of steps, and then we used to solve the problem stepwise. Because here the sequence of the decision steps will be the results for the dynamic optimization, because here the data changes over the time. So that type of optimization is known as dynamic optimization. So how, see, in optimization problem we need to construct the mathematical model, and for that we have some structure of mathematical problem. First of all, we used to construct the objective functions. We need objective functions, we need decision variables for constructing the constraints. So these are the main components, that is objective functions, variables, constraints. So to make the problem, to convert the problem, to write the problem in mathematical form. So objective function is represented as zx, which is the output researcher trying to maximize or minimize. So objective function is a function which needs to be maximized or minimized. And it is to be maximized and minimized with the help of the decision variables. That is x, y, z. It depends upon you. You are taking it as x1, x2, x3, and so on, or x, y, z, u, v, w. So these are called the variables, or you can say the decision variables. Okay, from which we used to form a constraints, the conditions we explain using the decision variables, and that should be satisfied in order to optimize the objective functions. Decision variables are also known as the inputs. That is, researcher can control. They are abbreviated xn to refer to the individuals or x to refer to them as a group. So it may have one variable, two variable, three variable, or group of variables. Constraints, which are equations that place limits on how big or small some variable can get. So this is limit, you can say, resources, how much resources we can use, that is represented by the constant. So this is objective functions, variables, constants, all we need to formulate the problems. How to formulate the objective function? Objective function expresses one or more quantities which are to be minimized or maximized. It may linear, it may non-linear, it may quadratic. There are so many types of objective function. There is a single objective function, multi-objective functions. So basically, objective function represents expressed as the function which is to be maximized or minimized. It depends upon the problem that how many decision variables we have to input in the objective function. Which type of what is the character of the objective function? It may linear, it may non-linear, it may quadratic also. It may have more than one objective function. That is also known as multi-objective function. Some problem has more than one objective. So the optimization problem may have single objective function, more objective function. Usually the different objective functions are not compatible. The variables that optimize one objective may be far from optimal of the others. The problem with multi-objective can be reformulated as single-objective problems by either forming a weighted combination of the different objectives or by treating some of the objectives as constraints. So this tells you how we formulate and how we use to solve, how you represent the multi-objective functions. In manufacturing, if we talk about the manufacturing, it is to maximize the profit or minimize the cost of the production. Whereas in fitting experimental data to a model, it is to minimize the total deviation of the observed data from the predict data. Here I have shown you that this is the function that we need to optimize, and this is the way how we represent. This is the linear function basically. We are showing you the objective function which represented by z is equal to c1x1 plus c2x2 plus so on for nth variable, that is c and xn. In combined form, we are using a summation sign. taking from j is equal to 1 to n, where c1, c2, cn all are constants. x1, x2 till xn's are the decision variables, or you can say simply variables. So this gives you the linear form of the objective function. The variables, a set of unknowns which are essential are called variables. The set of unknowns for which first of all we will find out the value of the known, value of the variables. That is why it is known as a set of unknowns. And we will finding the values in such a way that it will satisfy the constant as well as the objective functions. So it is the set of unknowns. Okay. So the variables are used to define the objective function and constants. One cannot choose design variable arbitrarily. They have to satisfy certain specified functional and other requirements. It is only for the constant optimization. That otherwise not in unconstant optimization there is no restrictions. We don't have to fulfill any requirements. So the design variables can be continuous, discrete or Boolean. In manufacturing, the variables may be the amount of which each resource is consumed or the time spent on each activity, whereas in data fitting, the variables would be the parameters of the model. The solution of the optimization problem is the set of values of the decision variable for which the objective function reaches its optimal value. If the set of values of the decision variable are good enough, then it will surely optimize the objective function. But it has to satisfy certain limits, certain requirements. Constants. The synonyms of the constants, that is limitations, restrictions. A set of constants are those which allow the unknowns to take on certain values but exclude others. They are conditions that must be satisfied to make the decision to be feasible. The constants are the functions that describe the relationship among the variables and that define the allowable values for the variables. Same thing, it may represent equality, it may represent by inequality, race, linear. Here you can show and see how we can represent any constants. Again, we are taking the help of decision variable, that is xj. Aij is the coefficient. It may constant, it may take any variable, it is linear or non-linear. So this is the way of representing the constants. Sometimes it is less than equals to, sometimes it may represent by equality, and sometimes it is greater than equals to. Sometimes it is given by the range, that from this to this we need to find out the variables. Some bounds are given. So this is the way of representing the constants. So basically, objective functions, variables and the constants. From using these components, we model the problem. This is the classification of the optimization problem. Optimization problem can be classified based on the type of constants, nature of the design variable, physical structure of the problem, nature of the equations involved, deterministic nature of the variables, permissible values of the decision variable, number of the objective functions, and so on. This is a very vast field, very vast field. And there are so many ways to classify the optimization problem. So here you can say, based on data we have optimization is classified among uncertainty, deterministic and multi-objective optimization. Basically, it is divided into two parts, that is uncertainty and deterministic. Somehow you may take it in multi-objective optimization also. Again, you can see uncertainty is further divided into stochastic problem and robust optimization. And further, this deterministic is divided into the continuous and discrete. We discussed earlier what is continuous, what is discrete. So, further you can see continuous and discrete is further get divided into unconstant and constant, that we also discussed. Discrete is further divided into integer programming, when the integers involved in the problems. And then combinatorial optimization. This is also one of the very important and popular optimization. Then again, unconstant optimization is divided into non-linear least square, non-linear equations, non-differentiable optimization, global optimization. Again, constant optimization is further divided. You can see non-linear programming, network optimizations, bound constants, linearity constants, and so on. So in this way, it is the optimizations. We have optimizations classified depends upon their physical nature of the problem, depends upon their number of variables involved, the type of data involved. Okay, so in this way we can classify the optimization problem. See, here we have taken the heuristic approach and the meta-heuristic approach in classifying the optimization problem. Heuristic approach. See, when we see the problem and start thinking in our mind, start our calculation, our planning, how we can solve this problem. That is heuristic approach. Any approach to problem solving that uses a practical method, you can say, or various shortcuts in order to produce solutions that may not be optimal, but are significant or you can say sufficient, given a limited time frame or deadline. If we don't have a whole day, we have a limited time, limited restrictions, then we start doing moving towards the solution. That is known as heuristic approach. Meta-heuristic approach, you could say that a heuristic exploits problem-dependent information to find a good enough solution to a specific problem. While, meta-heuristic is the broad sense where complex type of problem we are taking. But in heuristic, mental shortcut thinking process problem, we can say, where we can use this mental shortcut method, or solutions are not expected to be perfect or optimal here. But we somehow we raise the solution whether it may optimal or not. But in meta-heuristic system, it is like a design pattern, general algorithm ideas that can be applied to a broad range of the problem. So here in optimization, we are using a meta-heuristic approach. The optimization technique broadly divided into three categories. One is swan-based algorithm, trajectory-based algorithm, evolutionary algorithm. Swan-based optimization, that is based upon the some you can say properties of some species, swarm. Many optimization algorithms have been developed by drawing inspiration from the swarm intelligence, mostly inspired by biological system. Swarm intelligence adopt the collective behavior of an organized group of animals as they strive to survive. It is further divided into swarm-based. Under the swarm-based algorithm, we have some techniques available. That is artificial ecology, cuckoo search, firefly algorithm, particle swarm method, So these are the algorithms, these are the techniques based upon the swarm intelligence, where we take the techniques from the collective group of an animal, how they behave with the nature, how they behave to survive. We use their techniques. So this type of methods is known is comes under the swarm based algorithm. Trajectory based algorithm. Trajectory based optimization is a technique for computing the open loop solution to an optimal control problem. It is often used for systems where computing the full closed loop solution is not required, impractical, or you can say impossible. So, hill climbing, big hill climbing, simulated annealing, taboo search, these are the methods, these are the techniques, advanced optimization technique, I can say, comes under the trajectory based algorithm. And the last, but this is very, very important, that is evolutionary algorithm. It uses the mechanism inspired by the biological evolution, such as reproduction, mutation, recombination, and selection, where the algorithm inspired by the nature. They take the rule, regulations, the way of living, survival from the nature, and the methods, that is differential evolution, genetic algorithm, genetic programming, harmony search, these are the techniques comes under the evolutionary algorithm. Among these, we will discuss today about the genetic algorithm, which is a very, very popular advanced optimization technique. Again, this is the parameter involved. I am skipping this part. This is comes under the problem that this is the parameter. I mean the how we select the parameter for the constant, for the unconstant type of problem, for dependent type of problem, independent type of problem. So it depends. I have discussed this earlier also in the previous slide. That for constant we need not to for the constant we see the restrictions for the work given, and according to that we use the our variables, and the constant no restrictions to carry out the work. Similarly, dependent directly under the control of the researchers, thus independent is we can say independent variables we can use. Here is the techniques, characteristics, property, and then the type of technique, the type of problems we can say comes under these categories. For example, if it is if the variable is one, we can say it is a univariate problem. If variables is number more than one, it is multivariate. If it is continuous, then continuous. We have discussed this also. Here some traditional and classical methods are given in the left hand side of the table. And in the right hand side, I have given the advanced techniques, some advanced optimization techniques. Previously, we were using linear programming for the linear problems. For the integers type of problem, we have used integers programming, quadratic programming, non-linear programming, dynamic programming, but it has some restrictions. For the complex type of problems, these methods fail because it is not necessary that in every problem is differentiable. Somehow, in some case, it is not. There are so many restrictions. Not only the differentiability of a function, but there are many more restrictions where this traditional method fails. That is why we are using advanced techniques. This is here we have the methods which are gradient, which is not gradient, non-gradient, simulating annealing, graph method, GRA, evolutionary optimization, that is genetic algorithm, neural network based optimization. So many I have listed out approximately all the optimizations technique here, which we are using in research. Advanced optimization techniques mainly helps you to achieve the global optima. Using this figure, I want to show you that by the classical techniques or traditional method, we can stuck at the local maximum optima, and we think that this is our global optima, because it is not possible to reach up to global optima using the classical method or traditional method. But in advance, if we use the advanced optimization technique, we can avoid these local optima and we achieve more global optima. Steps for selection for optimization method. First of all, we define the problem and decide the problem class where it is associated with. Then we need to have close look about the literature using the problems, and then we see the types of problem. We classify the objective functions, decision variables. According to that, we formulate the problem. This is also primary investigation of the system behavior. We should investigate the system behavior, selecting the appropriate optimization approach based on investigations, executing and evaluating optimizations. These are the steps involved for the optimization. Here, in the short form, in the very compact form, I am showing you the flow chart of optimal design procedure. First of all, if we are needed in optimization, we are doing work for the optimization. We choose the design variables, we formulate the constraint, formulate the objective function, set up the variable bounds, then choose the optimization algorithm and obtain the solution. Just check the solution whether they satisfy the variable bounds or not. If it satisfies, then we can come out to the optimization algorithm, we come out to the end. But if it's not satisfied, then again we choose the design variables, whether it is correct or not. Again we formulate the constraints, and then we satisfy the objective function. So it will terminate when we achieve the optimization, we achieve the goal. Then we can terminate this procedure. So it will go on changing the decision variable, it will go on changing the formulation, it will go on evaluating the objective functions until we reach the goal. So genetic algorithm, this is the technique we are using here. I am discussing here about the genetic algorithm. This is one of the most important and popular optimization technique, which is based upon the nature, and nature never fails. So nature has always been a great source of inspiration to all mankind. Genetic algorithms are search-based algorithms based on the concept of natural selection and genetics. GAs are the subset of a much larger branch of computation known as evolutionary computation. Genetic algorithms were invented by John Holland in early 1970. Genetic algorithms are a part of evolutionary computing, a rapidly growing area of artificial intelligence. It is inspired by Darwin's theory about evolution and survival of the fittest. So, genetic algorithm is the evolutionary algorithm which takes the rule. Excuse me. Yes. From the which takes the rules from the nature. See, those who can fight will survive, and those who cannot fight who will not able to survive here. It applies all where. In human also has to fight for their survival. All the species, animals. Okay, so, for example, if you take a herd, a group of deer in a forest, and suddenly one lion comes, those who run fastest can survive their life. and those who cannot will lose their life. So again, in another day, again, it runs continuously in our system, in our environment. Those who are survived, it means they are fittest. Every day, in every second, every time, everyone has to fight for their survival. So this is the rule we are in genetic algorithm we are using. What we do in genetic algorithm, we have a set of possible solutions. We can say a population of solutions. Solutions undergo recombinations, mutations, crossover to produce a new children, and the process is repeated over various generations. Each individual's or candidate solutions, you can say, is assigned a fitness value. You can say a fitness value, it means the objective function. And the fitter individuals are given a higher chance to make and end more fitter individuals. This is in line with the Darwin theory of survival of fittest. In this way, we keep evolving better individuals or solutions over generations till we reach a stopping criteria. Here you can see, first we have to evaluate. We evaluate according to our objective functions, fitness value, and then we select among the populations the best value. We will select the best value and reject the worst one. Then we use the technique, genetic technique, that is crossover, mutations, recombinations. And then again we include it in a set of solutions. Again we find out the fitness value. Again we do the selections, and so this process will go on. So see how we can understand in a simple way. Suppose I want to create a country where only intelligent people will live. Only intelligent people. So we take all the intelligent people from all the countries. We will select the only intelligent people from all the countries and put it in a new country. Then the offspring of our new countries will be the fittest individual, you can say, or the more intelligent one. And generation to generation, their intelligence will increase. So genetic algorithm based upon these concepts. And in this way, we can optimize our solutions. We can get the best to the best solutions, iterations for iterations. So, some terminology we use, basic terminology, that is populations, chromosomes, genes, LA, for these in genetic algorithm. So, we should know these terms also. What is population? It is a subset of all possible encoded solutions to the given problem. All the possible solutions we are taken as a population. All the population. You can see in this, all the possible solutions are taken as a population. And each solutions represent as a chromosome. Because this is a technique, genetic algorithm is taken from the biology. So with the terms, biological terms are here, that is chromosome, genes, LA. So what is chromosome? One such solutions among the population is termed as a chromosome. A gene is one element. A gene is one element position of a chromosome, and LA is its value. That is 0, 1. This is known as LA. This box, this position is known as gene, and this is known as a series of the binaries, the 0 and 1 is known as the chromosome, and the set of the chromosome is known as population. We should know about the encoding and decoding, that is phenotype space and the genotype space also, because we use the computation method. So we need the computer needs their own way to understand the problem. So first of all, we have to encode the problems in a computer language so that a computer can easily understand the problem. So there are two terms, that is phenotype space and the genotype space. Genotype space is the where the solution is in a language of a computer, and the phenotype space is a real world solution that human can understand easily. So the real world problem is encoded and get entered into the genotype space. And after getting the solution, the genotype space can come out and by decoding to the phenotype space. Here I have defined the genotype. Genotype is the population in the computation space that the solutions are represented in a way which can be easily understood and manipulated using a computing system. The set of genes representing the chromosome is genotype, which can easily be understood by the computer. Phenotype is the population in the actual real world solution space in which the solution is represented in a way that are represented in real world situations. The actual physical representation of the chromosome is phenotype. For example, if we take the binary of this, that is 7, the 7, the binary representation of the 7 is 0 and 111. This is the genotype representation. And 7 is the phenotype representation. Any human can understand 7 easily. And this is the genotype representation that is easily entered into the computer and it can be understood by the computer language easily. So decoding and encoding, this is also a process. For simple problems, the phenotype and the genotype space are the same. However, in most of the cases, the phenotype and the genotype space are different. Decoding is a process of transforming a solution from the genotype to the phenotype space, while encoding is a process of transforming from the phenotype to genotype space. So decoding should be fast as it is carried out repeatedly in J during the fitness value calculation. So one loop is going on in computer. When we start solving a problem, then one loop is continuously running into the computer. You continuously find out the value of the fitness value, you can say object value of the objective functions, and decode the value. What is a fitness function? A fitness function simply defined is a function which takes the solution as input and produces the suitability of the solution as the output. In some cases, the fitness function and the objective function may be the same, while in others it might be different based on the problem. So fitness function is the objective functions from which we use to evaluate our good solution. So this is the criteria every solution has to pass through. Genetic operators. Genetic operators are mainly that is crossover mutations and selections from which we use to improve our solutions and get the better solutions. This here I have shown you the basic structure of the genetic algorithm. Basic structure. This is very simple. First we start the problem. We collect all the solutions, that is known as initialize the population, you can say. Then we evaluate all the individuals using our fitness criteria, fitness function. Okay, and we stop. If we get the best individuals, we can stop, we can get the result. But if we are not stop, if it is not satisfying the termination condition, there will be a termination condition defined in each and every question, every problems, where we need to stop, which type of solutions we want, what are our conditions of optimality. According to that termination criteria we used to decide. So if it is not satisfying the termination criteria, then we go to the reproductions. We choose the parent. We choose the best parent based upon the evaluation. Then we do reproductions, crossover, mutations, okay, and then again the new solutions came. Again we go to the fitness functions, evaluate the new offspring. Again we see whether it is matching our solutions, our stopping criteria or not. According to that we move further. Now, chromo representation and evaluation. This is one of the basic main important steps that we have to represent our problem in a binary way. Also, there are different representation available for the chromosome and the selections for the proper representation. It depends upon the problem. The good representation is what makes the search space smaller and thus easier to search. The representation available for the chromosome includes binary representation. Binary representation, that where the chromosome is represented as a string of zeros and one. Permutations. We can also use the alphabet, numbers for the permutation. Basically, it is used in traveling salesman problem. We can also use the problem in our values, actual values. It depends upon the problem, how you use to represent the solutions. After representing each chromosome, the right way to serve the search space. Next is to calculate the fitness value. For example, if the fitness value is given by a function of x is equal to 2x plus 2, then you put the value. For suppose we have taken the 7 in last slide. So if we put the value 7, you get the 16. So this is called the evaluation. You are putting the value of the solution to the fitness value and see the result. And you according to that you will select the better solution. So this is called the evaluation. Process of calculating the fitness value of a chromosome is called the evaluation. So every chromosome depends upon the time, depends upon the needs. Okay, if you can select the chromosome randomly also, or you can choose. You can take all the chromosomes at once and check their fitness value. And according to the fitness value, you can choose to proceed further, and you can choose that chromosome for the further steps. So, genetic algorithms, selections, crossover and mutations. First of all, we need to see how to select and the individuals, the best parents you will select, the best offspring you will get. So first of all, this is the first step is very, very important to select the good parent. And then we will go through the crossover and mutation. Selections, the process of determines which solution are to be preserved and allowed to produce and which one deserve to die out. The primary objective of the selection operator is to emphasize the good solutions and eliminate the bad solution in a population while keeping the population size constant. Darwin evaluation theory, the best one should survive and create no offspring. That select the best, discard the rest. So that is why this selection, select the best one. It takes from the Darwin evolution theory. Select the best, discard the rest. So this is very, very important steps. Selection method, selection operator, one of the most important operator of the genetic algorithm. And there are so many techniques available. And it depends upon the problem. Depends upon the time, you can use the selection method. First one is tournament selections, round-the-wheel selections, proportionate selections, rank selections, steady-state selections, random selections, etc. Tournament selections. In tournament selections, several tournaments are played among a few individuals. The individuals are chosen at random from the populations. The winner of such each tournament is selected for next generation. Very simple. Selection process can be adjusted by changing the tournament size. Weak individuals have a smaller chance to be selected if tournament size is large. Then we select only a very strong individuals. So that is known as tournament selection. This is a very simple round wheel selection. In this, a fixed point is chosen on the wheel circumference as shown here. Okay, so here you can see in a hotel or resort, a club, sorry, where you can see in club we used to play. So that wheels is taken here, and the point which get the better chance, the good chance or maximum chance to choose will be the fitter individuals, which has the greater size of a pie on the wheel will get the greater chance of selecting. So we keep the point, see here it is in table, you can see the chromosome is taken and the fitness value is taken, and then according to this we take the wheels, and if you rotate the wheel, the greater chance to get a chance to select is the area which has the greater circumference, the color which has the greater circumference. So this is one of the methods of the selections. Rank selections. We use the rank selections where the fitness value, all the chromosomes have the same equal fitness value, and they are very hard to choose the best one because all are having very less difference. So in that we used to create a rank and then choose the individuals based upon the rank. See here you can see according to the fitness value we have given a rank to the chromosome, and according to their rank we can choose the best individuals. And we use rank method when all the individuals, all the chromosomes have nearly same value. Steady state selections. In this method, a few good chromosomes are used for creating new offspring in every iteration. They are not going to change the solutions again and again. They are not going to choose the parent again and again. They are taking some good parent in a one choice, in a one selection, and they are using that parent again and again in each generation. Their offspring is again become a good parent, then they will yield a new offspring. So same generation is used for same parent is used for the generation. So this type of selection is known as steady state selections. Random selections, where we select the parent randomly. Where we see if a group of good people are there, so we don't have to spoil time in selection criteria, choosing the selection criteria. So we select all the parents are good, we can select randomly any two parents. So this is comes under the random selection. Crossover and mutations are the two operators for the genetic algorithm. Crossover is a one-point crossover, you can say, multi-point crossover, you can say. This is one chromosome. This is one chromosome taken. Okay, if we change their LA, if we are taking a cut after 3 bits, and then their bits are swapped. So this technique is known as crossover, and new offsprings have made. So this is a crossover. During crossover, we create new individuals by combining aspects of our selected individuals. Suppose we have selected these two individuals and then we are creating new offspring using the crossover. Here also you can see there are two chromosomes, two sets of chromosomes are taken. One red line shows that we are taking doing the crossover operator, so using the crossover operator after a 5 bits. Now 3, 5, 7, 5, 8 of second chromosome will get swapped with the first chromosome. And in the same way, you will get a new offspring. Then again, we will find out the fitness value of these chromosomes and we will see whether their fitness value is increased or not. If it is increased, we will choose. If it is not increased, we will discard this chromosome. So the 2-point crossover, there will be two breakpoints. If there are 2 points crossover, where we are applying the crossover operator on 2 points. You can see after the 3 bits also we are applying the crossover, and then after the 5 bits also we are applying on 2 points we are applying the crossover. So this type of crossover is known as 2 points crossover. Similarly, there are multi-point crossover also, that here you can see there are 2 set of chromosomes are taken, 0, 1, 2 is get swapped with 5, 8, 9. Then again you can see 3, 4, 5 you can also get swapped. So any points, if you can swap more than 1 point, then it will come under the condition multi-point crossover. Uniform crossover, if we decide one rule that every alternate allele will get swapped with the another chromosome, then it will come under the categories of uniform crossover. You can see in the path also. Here in this diagram, I am showing you the crossover taken actually on the path. How it apply on a path. Here it is a crossover. See, red line comes and joined with the blue lines. In the result, you can see the red line is combined with the blue line. So this is the path where it is used in robotics. So in the path also we are using the crossover technique. Next is mutation. Mutations, if the chromosome is swapped, the bits, the digit, or you can see the allele among them. Mutations involve reordering the list, you can see. Mutations apply to each child individually after crossover. If the result is not met our criteria, then we can go for the mutation also. You can see in here the 5, 8, 7, 2, 1, 6, 3, 4. Here 7 and 6 get swapped. A new offspring you can form using the mutation operator. This is bit plate mutations where one bit gets swapped. Scramble mutations where the number can scramble. Inversion mutations where the bit can inversely swap, then it comes under the category of inversion mutation. So there are so many ways you can mutate. You can use the mutation operator and get the best offspring. GA termination conditions where there has been no improvement in the population for the X iterations. After X iterations, if there is no improvement in the population, then we can stop there. We can terminate our conditions there and get the solution. Or when we reach an absolute number of generations, then also we can stop. When the objective function value has reached a certain predefined value, if we fix that this is the value we want to reach, then if we got that value, we can stop. The termination condition decides when the algorithm stops running. The most likely reason is that your algorithm has found a solution which is good enough and meets a predefined minimum criteria. So under these conditions, we can terminate our loop. our problems and get the solution. That the solutions we get will be the optimal solution. So we are using these examples to show how we use the genetic algorithm. Suppose a genetic algorithm uses a chromosome of the form X is equal to A, B, C, D, E, F, G, H with a fixed length of 8 genes. Each gene can be any digit between 0 and 9. Let the fitness of individuals X can be calculated as this is the fitness value and this is the gene taken. Chromosome is taken with the A, B, C, D, E, F, G, H. Okay, and this is the fitness value. So, let the initial value population consist of 4 individuals with the following chromosomes. Suppose we have taken X1, X2, X3, X4, 4 chromosomes from 0 to 9. Randomly, you can you can change this value also according to you. So, take any value from 0 to 9, take 4 chromosomes, put the value of each chromosome in the fitness value. See, here we finding the fitness criteria for each chromosome. For first chromosome, you are getting the value 9. The second chromosome gets you the value 23. The third chromosome gets you the value minus 16. And the fourth value is giving the value minus 19. So this is the fitness. This is the fitness value of all the chromosomes. This is a very simple example to understand the genetic algorithm. So if you see, we arrange the chromosome in ascending order. The best one will be the first and then so on. Then X2 will be the best. X2 will be the best chromosome to take for the further process. Then X1 will be the best. After X2, X1 will be the best. Then X3 and then X4. So according to the fitness value, we choose X2 and X1. 2 solutions we have taken for the further process. Now we perform the crossover. This is X2 and this is X1. We have taken the chromosome of X2 and X1 and we perform crossover technique here. What we did here? We swapped their beds. After 4 digits, you can see 6601 went to X1 and 3532 went to X2. So X2 and X1 get swapped and form a new offspring, offspring 1 and offspring 2. So you can see offspring 1 and offspring 2. Now again we find the fitness value. Now the fitness perform the we can perform the mutation also for getting the optimum solution. Again find the fitness criteria. So initially we get fitness chromosome is Fx is equal to 5. Now if we perform mutation operator on the chromosome, mutation it means to interchange. Either you place 1 in place of 0 or 0 in place of 1. Then we get 6. So in this way, we increase the value of the fitness. Now, genetic algorithm you can apply in controlling the system, designing, game playing, security, robotics. Vast application is design, aircraft design, any designing of any vehicles, communication networks. In robotics also you can see that there are vast applications of the genetic algorithm in robotics is present in the research. You can see automatic design using genetic algorithm. Engineering design, we can see design a heat exchangers robot, gripping arms, satellite booms, building trusses, etc. So you can see, we have used the genetic algorithm in many ways. Any question? That's all from my side. If you have any question, you can ask.
Okay, thank you, ma'am. Thank you, madam, for valuable talk about the optimization technique. Brief
Thank you.
explaining of the optimization technique.
Thank you.
So, participant, please, any queries, please put your question in the chat box. We'll revert it and try to give you to answer. Okay, thank you, ma'am, once again.
Hello, madam. Good morning.
Sir.
Madam, really, it was such a nice, you're delivering lecture. And I have, for the last these hours, 1.5 hours, I am sitting and I'm just attending your lectures. And I'm very happy to see the new and this genetic algorithm. I was fond of this genetic algorithm for so long time. So, madam, what about the different methods? If suppose I'm applying genetic algorithm on any problem, and I'm getting the solution against that, and the other method, if I'm applying the other method on the same objective function, then definitely we will get some some solution of that objective function. So how those solution will be means how I can relate or I can judge which is the best means solution, and on what basis we will finalize that GA is giving me the best solution, because nowadays ant colony and all different bee colony and different methods have come into the the research area, research field. So can you throw some light on that so that we can get it clear?
So first of all, see, it depends upon the nature. It depends upon the type of the problem we used to take, and it depends upon the method we are using. Basically, you will find that very 2% of variability in the solution is there. So, and it depends upon that how easily you can apply any techniques, and it depends upon the time also. So there are so many parameters to decide the from which way you choose the optimization technique to any problem.
Thank you, madam. Thank you. Thank you. I got your point, ma'am. Thanks a lot.
Thank you, madam. Thank you for nice presentation once again. Due to the shortage of time, the queries of the participant, please put your queries on the chat box. We will try to answer through the madam in later case. Okay, sir. Dr. Jitendra.
Okay. Thank you, Dhanasar sir. Now we are in the last technical session, and we have with us Dr. Bineet Sekhar. So I would like to welcome and introduce the speaker of this session, Dr. Bineet Sekhar. It is my great pleasure to introduce Dr. Bineet Sekhar, speaker of.
Good afternoon, sir.
Yes. I hope the session will be very informative. Just I go through his brief description. Dr. Bineet Sekhar has completed his PhD program in Department of Electrical Engineering from BIT SINDRI under VBU Hazaribagh in 2016. His area of research interest is in fractional control, artificial intelligence, and real-time implementation. He graduated from North Maharashtra University, Jalgaon in 1999, and post-graduation from Delhi College of Engineering, Delhi in the year 2009. He has 19 plus years of teaching experience as a faculty. He has taught a number of courses in electrical engineering. He has supervised many students for their project works at BTech and MTech level. He has published a good number of research publications in international and national journals. He has he has applied innovative 4 national patents based on real-time application. He has delivered number of lectures in different reputed organizations. Dr. Bineet Sekhar is currently Associate Professor in Department of Electrical Engineering at BIT SINDRI, Dhanbad. So over to Bineet sir.
Yeah, good afternoon to everyone, and I'm thankful to Dr. Chandan Kumar and Dr. Chaitanya Sharma, the coordinators, the Dhaneshan Mato, and all the participants who have been attending this FDP. And I'm really thanks to Director BIT SINDRI, Dr. D.K. Singh sir, for giving a chance to the mechanical department to pursue this type of a FDP. So today I am going to be a simple presentation of the mechatronics and its operation. So in the current era, the mechatronics play a very important role in the designing and the applications in the industry. As we know that a few years ago in 90s or in the 80s, we found that all the work in the industry has been done by the manually. But initially in the Maruti Udyog Limited, where the Maruti 800, Alto and these cars are being designed and production is going on, the initial in India, the robotic system has been come in the operation. That robotic system has been came through the basic function or a basic design by the mechatronics. So before going to the mechatronics, how the mechatronics has been came in India. Initially, the mechatronics is being defined by the mechanic with the combinations of the mechanical, electrical, and the computer. So mechatronics is basically referred to the mechanical electrical system, and it is basically based on the mechanics, electronics, computing, and the control, which makes the system more simpler, economical, reliable, and versatile system. So the mechatronics in the foreign countries has been introduced in the year 1969 by T. Modi.
हाँ सर, बहुत बढ़िया presentation था.
He defined that the word of mechatronics is composed of mechanics.
Request Jitendra sir, please switch off your mic.
And the word mechatronics is composed of the from the mechanical engineering word that is mecha, and from the electronics. So the combination of both mecha and tronics makes a mechatronics. So in 1969, Dr. T. Modi has given a definition that the technologies developed product will be incorporating the electronics more and more into the mechanism, which is intimately and organically make it possible to tell where one ends and the other end begins. So in particular after that after 69 in 1994, Dr. Comfort had given a definition of who is the president of the Yasakawa Electric Company, Tokyo, that the mechatronics is the point by defined that it is the combination of mechanical, electronic, control, and the computer system. So in particular figure you have seen that the core branches, which has been basically a mechanical system, the electronic system, the control system, and the computer systems. These are the major part of a mechatronics. From all these parts, the sub-parts has been designed, which will be go in the earlier slides. So the next definition, which will be given in 1995, that the integration of the electronics, control engineering, and the mechanical engineering makes the mechatronics. So from the figure you found that from the mechanics, the word is mecha, and from the tronics, it is a tronics word, which makes the mechatronics. So here in 1996, the different person has given a different definitions. So in 1996, Dr. D.M. Oslander and C.J. Kempf given a definition that the application of a complex decision making to the operation of the physical system. In the similar way, in 1996, the Dr. F. A. Hasma and M. Tojomugo and D. F. Koda given the definition that the synergetic integration of the mechanical engineering with the electronics and the intelligent computer control in the design and the manufacturing of industrial products and processes. On the basis of this definition, the first initial robot system which will be introduced in the Maruti Udyog. After that, the next definition, which has been given by 1997, which includes the sensor and the actuator technology, which is a basic part of any mechatronic system. So it gave the definition that the systematic use of the precision engineering, control theory, computer science, and the sensor and actuator technology to design the improved products and processes. So in the similar way, we can say that the definition has been given by the number of people. In 1998, Dr. D.G. Ecloto and M.B. Stent given that the field of study involving the analysis, design, synthesis, and the selection of a system that combines the electronics mechanical component with the modern control and the microprocessor. This type of a system makes the mechatronics which comes in the real world. So when we use in the current era, we define the mechatronics, all the combinations of the definition provided from the 1996 to 1998. We say that the mechatronics is the systemic integration of sensor, actuator, signal conditioning, power electronics, decision and control algorithm, and computer hardware and software to manage the complexity, uncertainty, and communication of the engineering system. So in this particular figure, you found that the mechatronics is the basic, including the basic 5 different parts of engineering. That is mechanics, electronics, software, sensor, and the control. On the basis of this, we will talk about the mechatronics. So the next slide plays a very important role, how the mechatronics, the process has been designed. Initially, as per this flow graph, initially we have to know about what we have to need. Like what we required for the automation, what type of a manual system has to be designed for the automation. That is a recognition of the need, what you require. After that, you have to be make a conceptual designs and the functional specification. Means initially you have to be know about how they have to be work. Like in the case of a bottle filling plant, we know that the bottle will be empty. Once it gets filled, the valve will get closed. Then after the bottling, labeling should be done and the capping should be done. So initially we have to be know about the conceptual designs and what the function has to be done. What first step I have to do, the second step, the third step, and the fourth step. So initially when you make on a paper a conceptual design and the functional specification, we will go for its mathematical modeling structure. The mathematical modeling structure, how much delay is there, how much delay we have to be included in that one, which type of a sensor we have to be used, that all the theoretical aspects initially we have to be included in the conceptual design, then we make a mathematical modeling for that one. Once you make the mathematical modeling, then you have to move towards the selections of the sensor and the actuator. The sensor which sense the physical parameters and give the electrical output, whereas the actuator which take input as an electrical signal and give output as a mechanical in the mechanical terms. Once you select the sensor and the actuator, then you have to move towards the detailed modular mathematical modeling by including the sensors, mathematical operation, then digital formation of the signal, then which type of action you need to want, then after that signal, the actuator functioning and how it will be functioning in that system. Once you make the mathematical modeling in the MATLAB Simulink is there, LabVIEW is there. Once you make the mathematical modeling for that one, then you have to design the control system. Whether it is working in a feed-forward system or a feedback system having a different parameters. If you are working in a single input, single output operation, or a multiple input and multiple output operation. Means if you are taking as a sensor and multiple sensors, then we are using a multiple input, multiple output structure. But when we are taking a single action with respect to the single sensor, then we are using a single input and a single output system. Once the control system design has been done, then the design optimization can be done. The optimization methods can be done by using, as earlier the madam has, and Dr. Anupama ma'am has been discussed, that the genetic algorithm also come under optimization technique. There are different optimization technique by which we can get the controller actions parameters, how fast they have to work, how much delay we want to include that one. Once the design optimization has been done, then we make a hardware system. Hardware systems, a prototype system that is known as a hardware in loop simulation method, in which we can make a prototype system and we make data equalization system is there, sensor is there. Every function has been interlinked with the computer, and we will find out which type of output we are getting, whether the action is provided to the actuator or not, whether we are getting the signal from the sensor, how much amount of a signals we are getting. Generally, the sensor is always giving a signal of 4 to 20 milliampere, which is very low signal. So we have to amplify that one by using the instrumentation amplifier and the different techniques. Then once the hardware in loop simulation has been done, then we make a design optimization has been done. Once this process, the modeling, simulation, and the prototyping, once we make, then we use to make we want to make the prototype should be embedded in in a small component, which will be converted, in which the embedded software has been included. Once the hardware has been designed and the proper functioning has been gone, it should be run for a particular time being for in a test. You can say a test time is there. After that, what type of errors has been occurred, we have to determine that one. Or is there any limitation or any drawback, or is there any failure of the system, or there is a breakdown in a signal. By any means of that one, we can get that problems, and then we will move towards the what can we change the design or concept, so that we can get a desired output. These are the basic mechatronic design process by which we can go. So when we are talking about the modeling and simulation, this one, so we will start with the initial electrical elements, that is electromechanical elements. Electromechanical elements are basically having a sensor and actuators. As we know that the sensor, which basically sense the physical variables, like the photoresistors, level, displacement, which can be determined by the potentiometers. Then magnetic sensors are there, sounds, microphones. These are the sensors. Generally, everybody know about the sensors. We have different types of sensors. And the temperature by using a thermistor and a thermocouple. Then the humidity can be done by the conductivity sensors. These are the sensors in which the physical parameters can be measured and converted. In case of actuator, the electrical signal is provided, which we are getting from the sensor, and the electrical signals will provide it to the mechanical system, to the mechanical components, so that they can provide a mechanical output. Like in a DC servo motor or a stepper motor, we are providing the electrical signal and we are getting the rotation of the shaft. So this is done by the DC servo motor. Stepper motor, which will generally work on the digital signal, in which we are providing the pulse, and the stepper motor runs at a particular angle with respect to the digital pulse. In the similar way, we have a relay, solenoid, speaker, line emitting diodes, and these are been act as an actuator in the mechatronics. Then after that, the electromechanical system, we will move towards the electrical and electronics components. In case of electrical and electronics component, the electrical components are basically resistance, capacitor, inductor, transformer. which provides the analog signals. While in case of electronic elements, they are being analog and digital electronics, transistor, thyristor, opto-isolators, operational amplifier, power electronics, and signal conditioning. These all are the electronics components which will be used to control the electrical supply. So the electrical and electronic components are being used to interface the electromechanical sensor, which we have studied before, that is a sensor and the actuators. For that, we required for that interfacing we requires this electrical and the electronics components with the hardware elements. Then for the controlling and interfacing, for the control interfacing and the computing hardware, what we required? We required to convert the analog to digital signal. As we know that the supply which is provided to the motor is basically an analog signal. So from the computer we are getting a digital pulse. So we required the conversion of these pulses by using an analog to digital converter, then digital to analog converter, for digital input, digital output, that is known as a input output, then counters, timer, microprocessor, microcontroller, data acquisition and control board. This plays a very important role in the interfacing of the HIL system. Then we require a digital signal processing board. Once the control interface hardware allows the analog and digital interfacing, there should be a communication should be done between the sensor signal to the computer or a control computer, then the communication from the control signal from the control computer to the actuator. Means initially the sensor will be interfaced with the computer. That means we required a data signal should be passed from the sensor to the computer, then the computer to the actuator. So we can say the initial element is sensor and the final element where the mechanical action has to be done is done by the actuator. After that, the computer for which we required for all this mechatronics, the brain of the mechatronic system is the computer, where the information, all the information has been collectively ready, and the computer elements where the hardware and software will be utilized, where we can analyze, optimize, design and simulation can be done. How can we done it? By using a virtual instrumentation, rapid control prototype, hardware in-loop simulation and the PC-based data acquisition control. These are the major part of any mechatronic system in which we can make a prototype system and make a simulation and get the result before making any industrial purpose machines which will be based on the automation. Then once all the things we have studied, how can we determine or the elements one by one stepwise we can use. That is, initially we have a typical knowledge about the optimal design operation of the mechatronic system. Then which type of system we want to be a model, that is a dynamic system modeling in which we have a thermofluid. The mechanical faculty members know very well and the students. Thermofluids, structure, hydraulic, then electrical, biological. These are the dynamic system modeling and for the analysis. Then we have to take a decision and the control theory, which type of control would you like which type of controller would you like to have. It may be a proportional, integral, proportional derivative, proportional integral derivative. In the current era, there is a more artificial intelligence controllers are there that like AI based PD controller, AI based PI controllers, AI based PID controllers. Then the sensor and the signal conditioning circuit, sensor in which we have a different type of a sensor, and the signal conditioning circuit having op-amp based or an instrumentation amplifier is there. Then actuator, which will be work with the electrical supply connected in the output, will be derived by the power electronic circuit. Then the data acquisition system, which includes A to D converter, D to A converter, digital input-output converters, digital input-output, then timers, and the different components which are being in the data acquisition part. Then we have a hardware interfacing. Once you make a hardware interfacing by the data bus, then we will go for the rapid control prototype. And the last one is the embedded computing balance theory, simulation, and the hardware software. These are the basic elements for the mechatronics. show the design, these all the components, how they are being modeled in any system. Initially, we found that the mechatronics is in which the initial part is simulation and modeling, automatic control and optimization has been done by the information system is called. Then the mechanical, in which the actuator and sensor. From the mechanical system, we are connecting a sensor. In this particular part, the sensor part give this to the electrical system, in which we are just converting to 3 to 15 milliampere current to the higher value of the current, where this signal is basically analog signal, which will be converted into the digital signal by using an analog to digital converter, and it has been interfaced with a computer system, in which we have done some PID controllers and the control theory, and the simulation has been done. After that, the simulation is giving the output. That output is in the digital form, which will be get converted into the analog signal by using a D to A converter. This signal is getting converted in analog form, given to the electrical system. Here it is being get amplified and provided to the actuator. Actuator basically convert the electrical signal into the mechanical output system, and this system will be react on the mechanical system whatever you want. So this is the basic elements of the mechatronics. Then initially we will go through the what is a digital signal, what is an analog signal, how it get converted into the analog to digital and digital to analog. So initially the analog signal is basically having we know that the signal which is in the sinusoidal form is known as a. So in the analog signal, we are just having a direct pulse moving from the initial state to the final state and running in the continuous mode is known as the analog signal. But when we are talking about the digital system, in a digital signal, it is being a pulse type signal. Here you see that this is basically a digital pulse signal, in which the signal is being having a constant amplitude for a constant particular time being. So this is the analog system in which we are getting the analog signal, which is a continuous in time, where in this digital pulse we have a constant amplitude at a particular time being. So first initially we will move towards the analog to digital, that is a A to D converter. A to D converter is basically the continuous signal should be converted into the digital pulse signal. This particular green line indicates the analog input signal, which is a continuous signal, but it will be get converted into the digital pulse by using an analog to digital converter. In this, you found that this particular time being, the direct one pulse is there. Then after, it will be hold for a particular time being, for the another time being. Then it will be having a constant amplitude, which is based on this particular pulse. In a similar way, we are getting converted into the digital pulse. This is the interfacing of a sensor and the actuator to the DAQ card, that is a DAC card, data acquisition card. Initially, the mechanical system which is having a connected with the sensor. This sensor is providing 3 to 15 milliampere signal, which is being amplified by the instrumentation amplifiers, which is being by the amplifying electronics. This amplifying analog signal converted and given to the data acquisition system. The data acquisition system itself consists of A to D converter, D to A converter. It has been 8-bit or a 4 input, 4 output, 8 input, 8 output system is there, which will be done by the data acquisition system. Once the data acquisition system converted into the digital pulse, then it will be given to the computer, in which the control system design has been done, or a microcontroller to be given. Once it simulates the signal, then the data is provided to the data acquisition system, where it has been get converted into the analog signal. And the analog signal having only the output of 3 to 15 amplifier, 3 to 15 milliampere, then it is also amplifying by using the amplifying circuit. Then it is provided to the actuator. Actuator which can take as an input as an electrical signal and convert it into mechanical displacement position output, which is provided to the mechanical system. This is a basically, so for the interfacing, we require data acquisition system. For the data acquisition system, there are lots of companies which are providing a data acquisition card, that is a NI, Zeltom is there, NI is there, different companies which are providing the data acquisition cards. After that, this is the basic interfacing, that is a signal conditioning circuit which makes the signal, and the sensor output is in this particular, there you can find that there is a distortion in that one. After this, or its amplitude is very less, then the signal conditioning circuit is converting there is no any distortion in the signal, and the amplitude has been increased. This is given to this computer, and the computer includes the software and data storage and all the simulation parameters in there by using a MATLAB and a LabVIEW. That simulation has been run, and that signal is provided to the data acquisition hardware system. This data acquisition hardware signal gives a pulse in the digital form provided to the actuator, where it works in the physical phenomena and take a necessary action on that one. This is a single system in which we have a different physical system is there, like analog, digital, counter, sensor, motors. All these pulses are being provided to the analog signal. Once this analog signal is going to this D2A converter, then the digital pulse is converted, then revert back, and digital pulse is provided to this one, which will be converted into the analog pulse and provided to the necessary action to be taken. So how, what are the steps to be followed when we are using the data acquisition card? Initially, the sensor sensor measures the behavior of the system. Means the sensor is taking the physical phenomena, how much is getting changed. Like in a case of a temperature, we have a thermocouple and a thermistor where we can measure the temperature. On the basis of that, the sensor will sense, and this sensor provides the signal to the signal conditioning circuit, where it will be get amplified and filtered. So the second step is the output of the sensor is being conditioned, which will be amplified and the filter. After that, the signal conditioning circuit is provided to the analog to digital converter, where this particular analog signal is getting converted into the digital pulse. Once the digital pulse is get converted, then it is being given to the computer, where the computer can modify the system by outputting the control signal. The digital control signal are converted into the analog signal using D2A converter, DAC converter. Once the signal is get converted into the analog, then it will also be get amplified and filter and provided to the actuator. These are the steps in the data acquisition system. So in the DAC, there is a conversion of analog to digital. How can we convert the analog digital signal? There is that can be done by 2 power of n, and it will be get converted into the digital pulse. Here you can see the conversion of analog signal into digital. This particular indicates the single bit of the analog conversion to the digital conversion, where this having 2 bits of data 00011011, which can be done by R2R approximation method is there. So this can be done by the 2-bit analog to digital conversion. Then we have a 3-bit in which we have a conversion of 0003. We have a 3-bit of data which will be converted into the digital pulse. Then the sensor. What do we have? Sensors which take an input signal and give an output signal, in which it will sense. The sensor is basically which sense the physical quantity parameters and converted into the suitable signals or a suitable processing signals, like optical, electrical, and mechanical. The sensor basically converts the measurement of the physical phenomena into an electrical signal. The active element of a sensor is called as a transducer. As we know that RTD, thermistor, and then strain gauge, all are the transducers, and the active element in this transducer act as a sensor. So the transducers, the device which converts the one form of energy to the another, whereas when the input is the physical quantity and it converted into the electrical, then it will be act as a sensor. Whereas when the input is electrical and the output is physical quantity, then it will be act as an actuator. So in this particular block, you find that the sensor in which the physical parameter is getting converted into the electrical output, whereas in the actuator you found that the electrical input get converted into the physical output. So these are the some examples when the force is getting converted into the voltage. It means the physical parameter is getting converted into the electrical output, then it will be act as a sensor. Whereas in the voltage is getting converted into the force, then it will be act as a actuator. This will be known as a sensor and the actuators. These are some sensing elements which will be used in the like biological, chemical, electric, electromagnetic, then optical, radioactive. For this we are using a different sensors. How can we convert this? How this sensor will convert in the which parameters? There are some physical parameters like thermoelectric. That means the heat temperature is getting converted into the electric. Thermoelastic like strain gauge. Bimetallic strip is there in which the heat is provided to the bimetallic strip and the bimetallic strip is changing its position. So then we have a thermomagnetic, then thermo-optic, then the photoelectric. That means the light is getting converted into the electrical signal. Photoelastic, photomagnetic, then electrostatic, electromagnetic, then magnetic static. These are the common conversions in which the heat how can convert into the electric, then elastic, then magnetic. How the heats are being converted into different sensing elements by in the different form. In the similarly in the chemical and the biological. Then the commonly used the quantities for which in the acoustics we are using the wave in which we have to determine the amplitude, phase, polarization, then spectrum. These are the some different quantities, physical quantities will we can how can we change the parameters. Like in the electric we have a charge, voltage, current, electric field. We can measure these things using some sensors. Then the choosing of sensor. This is the important part in the mechatronics where which type of sensor we have to be used. Sensors, some of the environmental factors which are been very much affect the choosing of the sensor. That is which type of temperature range you required, humidity, corrosion, science, overall range, where we are using the sensor. In the industry, we have a different sensor we have to be used, like for the very high temperature, we are generally using the thermocouple, but for the low temperature up to the 50 degrees centigrade or 40-45 degrees centigrade, we are generally using the thermistor. In the similar manner, for the how range should be there, how much consumptions are there, which type of a system we are using, whether we are using an open loop system or a closed loop system, these all the economical environmental factors are being there. Then while choosing the sensor, the three important parameters are important in the physical mean, that is what is the cost of a sensor, whether it is availability of a sensor, then the lifetime, what is the reliability of particular that sensor. Then the sensor characteristics, what is the sensitivity of, whether it is a plus minus 5% or a 10%, what is the range, the minimum range and the maximum range, then stability of the sensor, then repeatability, linearity, error, response time, the frequency response. These are all the instrumentation parameters which will be used in the sensor, determine the sensor characteristics. Then why we require the sensors? Sensors are basically used in the different, you can say that in the different applications. So this make the system to be embedded in our bodies, automobiles, airplanes. It can be easily connected with the physical parameters. Like in a car, we have a open and close of the switch. We generally use a sensor which will be easily embedded in our car bodies. Then the another sensor which generally use the mechanical person knows very well, that is a strain gauge, where it will be used to determine the motion, stress and the pressure. Strain gauge is basically in which we are providing the force or a pressure on the this strip in the terminal 1 to terminal 2 the gauge. When we provide the pressure on this one, there is an increase in the length, and due to the increasing in the length, the strain is getting increased and the resistance of the sensing element gets changed. On the change of this, we can measure by using the Wheatstone bridge and determine how much change in the strain gauge is occurred. In similarly, in the temperature sensor, we have a bimetallic strip, as I know, as everybody know that bimetallic strip in which we have two metals having a different coefficient. Due to the different coefficient, the bending properties of the metal B is higher than the bending properties of metal A, due to which we can the change in the position of delta, we can find out how much change in position is there. So it is the temperature on the basis of temperature coefficient, we can define the mathematical formula, that is L is equal to initial length bracket start 1 plus beta T1 T minus T0, where beta is the temperature coefficient, T is the final temperature, and the T naught is the initial temperature. Where it will be used? It will be used in the thermostats, where we make using for the break of the electrical connection with the deflection of that one. Then different other sensors are the thermistors. Thermistors made of a two word, that is a thermal and resistor. Means that due to the temperature there is a change in the resistance. So this is be given as a thermistor. The another one is a thermocouple. Thermocouple, where the two temperature difference make creation of the flow of a charge. So on the basis of that, Seebeck have given the definition that the Seebeck effect to the transform a temperature difference to a voltage difference. When the two terminals having a two different temperature difference, there is a movement of a charge from the higher end to the lower end temperature. Then we have an accelerometer, where we can use to determine the acceleration of the system, where the vibration, how much vibration is going to be done. Then the motion, vibration, blast, impact, and the shock waves we can use using the accelerometer. This is the real-time interfacing part, in which we are making a prototype of a system. In the prototype system, we have a sensor with the input conditioning unit. Then the input interface is there, and that is been done by the data equalization system, which is provided to the real-time computer. And the human interface is there. Human interface acts as an operator, in which we are making the control system simulation, which give the output to the output interface to the data equalization system, which give the analog signal. This analog signal is converted into the output conditioning unit and provided to the actuator. These are it is a hardware in loop system. The same as we have real-time interface, the same system is being used in the hardware in loop system. The last one, that is a very important, that is the importance of mechatronics in the automation. In the automation, how the mechatronics plays a very important role. This is the basic part of the mechanical system, in which initially first we will plan a process. This is that is the manufacturing process, and this is the design process. Initially, we will design the system. Initially we make the design, which type of design we require. Then what are the specifications for that one? Which type of sensors you require? Which type of a system you require? Which type of output we require? We will study all the feasible studies has been done, and all the information should be collected. Then after the concepts, once the design concept has been made, then we can make a software analysis has been done by using the analysis model. Then we design it and optimize the design and analyze its output. Once the design evaluation has been done, then all the design documentation has been done using CAD and CAM and CAE software. Once this design process has been completed, and the system has been designed, or you can say a prototype has been designed, then we will plan the process planning for the industrial purpose. For the industrial purpose, or you can say in the manufacturing process system, the production planning, the design and procurement of new tools, order materials, NC, CNC programming has been done. All this has been done at the production end. Once all the things, order of the material, which type of materials you require, then how much order have you got, all the NC, CNC programming has been done. This will provide it to the production. Once the production has been done, then the quality control, all the things comes in the manufacturing process. But the design process for the mechatronics comes under the design process of the system. Okay, it's a last slide. Thanks. Hello.
Thank you, sir. Your lecture was really informative.
Thank you, Vinit
I
Sekhar.
have enjoyed your lecture.
Thank you, sir.
Hello, Vinit sir. Thank you very much
Thank you, sir. Thank you, sir.
for giving your valuable insights on mechatronics and its application.
Right.
You have explained elements of mechatronics,
Yeah.
control interface, and computing hardware, and importance of mechatronics in automation in a very excellent way. Thank you. Thank you very much.
Thank you, sir.
Okay, now we'll proceed for validity function within 1 or 2 minutes.
Meanwhile, I will request all the participants to check their registered mail. We have sent a feedback form, link of feedback form. So kindly fill it. Your certificate you will receive your certificate by 12:50. Certainly. Before that, I request you kindly give your valuable suggestion or feedback so that we will able to improve next time. Please check your mail. If not received, drop a message. We will send you once again. Thank you, participant.
Hello, Chandan sir.
Yes, sir.
Now we should start.
ठीक है सर आ गए
Yes, yes, yes.
प्लीज
A very warm, good afternoon to all. Myself, Dr. Jitendra Nath Mehto, Associate Professor, Department of Mechanical Engineering, BIT SINDRI. On behalf of organizing committee, am I audible, sir?
Yes, 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 yes.
please mute your mic.
I welcome you all to the validity session. After successful completion of 1 week faculty development program on mechanical engineering emerging trend 2021 from 20 to 29th May 2021, organized by Department of Mechanical Engineering, BIT SINDRI, in collaboration with TechUp3. We are now at the end of this program. Now, I would like to request Professor Dr. S.K. Singh sir, Head Department of Mechanical Engineering, BIT SINDRI, to deliver his welcome address. Sir. Sir, please unmute.
Okay, am I audible?
Yes, sir.
Yes, yes.
A very good afternoon to our Honorable Director, sir, Dean Academic and Principal Coordinator, TechU Phase 3, Dr. Upendra Prasad, sir, our eminent speakers, my colleagues, and dear participants from all corners of the country. Today, we come to the last day of this fabulous workshop. I would like to thank all the eminent speakers, Engineer Rajkumar Singh, Professor S.L. Verma Sahab, Dr. Vivek Kumar, Dr. Anupama Singh, Engineer Om Ranjan Singh, and Dr. Vinit Sekhar Sahab. You all enlightened us with your expertise, sir. It will be definitely helpful for our colleagues, participants, and various research scholars in their fields. At last, I want to thank all the organizing team, our coordinator, Dr. Chandan Kumar, Dr. J.N. Mahto Sahab, Dr. Chaitanya Sharma, and Dr. Dhaneshwar Mahto. It is by the virtue of their hard work, this workshop totally meets the expectation of all of us. We definitely learned a lot of new technologies and techniques in recent trends in mechanical engineering, with hoping that in coming future, we will continue our efforts by organizing such interactive session in near future also. Thank you very much.
Thank you, sir. Thank you very much for your nice words. Moving to ahead, I would like to request participants to share their views and experience about the faculty development program.
Good afternoon.
Good afternoon, sir.
I am Praveen Misra from IIT Mesra. Good afternoon and warm welcome to all of you to this valedictory session of 1 week faculty development program on mechanical engineering, emerging technologies, organized by Department of Mechanical Engineering, BIT, SINDRI. The FDP was well attended by many faculties, many personalities of reputed educational institutions. The session of various talks presented by different faculties and from different industries, people from different, threw up their novel ideas in various fields of mechanical engineering. The 6 days FDP gave a lot of information on the new age emerging technologies to the audience by different invited guests, as by Engineer Rajkumar, by Dr. S.L. Barma ji, by Ranjan Singh ji, by Vikas Rastogi ji, by Vivek Kumar, by Anupma ma'am, and by Vineet Sekhar ji on mechatronics. Overall, the FDP was really nice one, truly well organized by maintaining time schedule. Once again, I thank the convener, Dr. S.K. Singh ji, HOD Mechanical Engineering Department, and course coordinator, Dr. Chandan Kumar, who has taken so pain to organize this FDP, and Dr. Dhaneshwar Mahto also, and also two course co-coordinators to organize such a good FDP. Thank you.
Thank you, sir. Thank you very much. Next participant.
Hello everybody. Good afternoon. Myself Vivek Singh from Galgotia College. This FDP which we have attended, that is a very nice, organized and very well planned. And I think the credit goes to Chandan sir also, as well as we have attended so many FDPs under his organizationship in when he was presently working in this Greater Noida area.
Thank you.
And if we talk about all these lectures delivered on these 6 days, I was very much impressed by the first 2 days lectures and Dr. Vivek Kumar's lecture. That was very nice. And others are also quite good, but I could not attend them sincerely as we are busy in our college activity. So, and today's lecture of Galgotia University, Madam, Dr. Anupama, it was also well planned and very well delivered. And in the last lecture given by Dr. Vineet Sekhar, it was very nice and very informative, which actually attracted my own interest in that area. So thank you all, and thank you for giving me opportunity to be present in this FDP. Thank you.
Thank you, sir. Thank you very much, sir, for your nice words. Next, please.
Good afternoon, sir. Dr. Rajiv Kumar this side. I am from the Department of Mechanical Engineering, Greater Noida Institute of Technology, Greater Noida. Sir, as sir has told, actually we were busy in our some academic, activities. We have not attended so many lectures, but what the session we have attended, really we have impressed with all speakers, right from Engineer Raj Kumar, who has delivered a very nice talk on reverse engineering and rapid prototyping. At the same time, Dr. S.L. Verma on metal matrix composite fabrication and machining. Engineer Om Ranjan sir, drone technology. Dr. Vivek Kumar, actually he is my friend also. We have already completed our MTech program from the same institution. So his lecture was really, right from the basic to the, the modeling of the rail track dynamic system. So I have really enjoyed his lecture on bond graph. And at the final session, Dr. Anupama, she has really, they have mesmerized by her lecture on optimization technique. She has clearly, she has delivered his very informative, her expertise in optimization technique. It was already shown by her lectures, delivering lectures. And at the last, the Vineet Sekhar sir, Dr. Vineet Sekhar sir has really, delivered his lecture right from the basic of mechatronics up to all the sensors, actuators. So altogether, the lecture was so beautifully planned and delivered in a stipulated time. And we at Greater Noida, we have seen this kind of lecture often. And I have seen the same kind of, the preparation and the time and all at the institute like BIT SINDRI is a worldwide famous institution, BIT SINDRI. And I thank all the organizers, all the faculty members of BIT SINDRI as well as Professor Chandan. He is really the man behind the success, I can say. Thank you so much for giving us opportunity to deliver, this the views or the final feedback of your FDP. Thank you so much.
Thank you, Dr. Rajiv Kumar. Thank you very much. Next participants, please.
Good afternoon to all.
Yes, sir.
Myself, Dr. Prashant Jahan, Dean Student Welfare from JSS Academy of Technical Education, Noida. So, first thanks to organizers, director and HOD for conducting a very wonderful program. And the name is quite good. NEET 2021, Mechanical Engineering and Emerging Technology. So, double meaning of this thing, and it's quite good. And from first day, the programs were very interesting, like 3D printing, bond graph, development of drone technology, and there's one very interesting metal matrix composite fabrication. And today's first is from Madam's side, overview of optimization and genetic algorithm, and the last one, mechatronics and its operation. I am also an analyst of NMU from this initiative, sir. So I again thank the organizers, directors and the HOD, the department to conduct a wonderful program, and please keep such programs in future also. Thank you very much.
Thank you, sir. Dr. Prashant Chauhan, sir. Next participants, please.
Good afternoon to all of you.
myself Dr. Tripathi. Sir, all the session was very interactive and all the lectures by all the faculty were very nice. And sir, I'm doing my research work and this is very beneficial for us for our research work. And sir, we will look for more DPs from this college DPT SINDRI. And thank you, sir. Thank you so much.
Thank you. Thank you. Next, please.
Very good afternoon, sir. I'm Dr. S.L. Verma. Am I audible, sir?
Yes, sir, you are audible. Sir, it will be nice if you switch on your camera, sir.
Sir, actually, not listening
Okay,
on
sir.
my
Okay,
camera.
sir.
And it saved off. And I am not in that dress today.
Okay, sir. Okay. Continue, sir.
So, actually, when my turn was there as a speaker, that day was Buddha Purnima. So, I had a wonderful feeling that day. That day was the day when Gautam Buddha उनको निर्वाण प्राप्त हुआ था, उनको ज्ञान प्राप्त हुआ था. And it was the day when I was sharing my knowledge on this platform with all the eminent persons. So I had a wonderful feeling that day. So that feeling I wanted to share with you. Next, my heartfelt appreciation to all the organizers for this FDP because we are sharing our knowledge and at the same time we are being benefited from the knowledge of other eminent speakers. Especially I am thankful to all the organizations, all the organizers, Dr. Chandan Kumar especially, who has worked out at very high pace to let this FDP happen in a short notice and without wasting time, and he recognized the right resources to be utilized. Basically, during this pandemic period, we have realized the full potential of online learning. This is the right platform whereby even you can access the knowledge platform when you are in your driving. At the last, thank you all the eminent speakers, sharing their knowledge, and also very much thanks to all the attendees. They have been there because unless they are not there, we cannot let this wonderful platform to work. This actually acts as a booster to all of us when it is well attended. Thank you very much to VIP SINDRI. Thank you very much.
Thank you, Verma, sir. Thank you. Next, please.
Good afternoon, sir. Myself, Dr. Akshay Kumar Rao from Bhubaneswar, School of Mechanical Engineering, KIT deemed to be university. Anyhow, what I found from last week, very nice, including all the topics, 3D and also optimization technique and mechatronics, because actually we have some learned, including my one PhD scholar. She is doing an optimization, also she has learned something. And one important thing is the time is very nice, because during this period, this is also lockdown, we have not faced any boring. We have spent our time nicely with the interaction of our respected lecturer, PPT, and also we have faced recently cyclone. We are lucky, there is no power cut anyhow. We have enjoyed a lot, and thank you, many thanks to our experts and also our director and the organizing executive of VIT SINDRI. Thanks a lot.
Thank you, sir. Thank you very much. Next, please.
Hello.
Yes, Girish.
Myself Sajay Giri from Bimetallic College of Engineering, Madhepura. I have attended almost all the sessions and it was quite interesting and informative, particularly 3D printing, reverse engineering, drone technology, and today's session for mechatronics. It has just created an enthusiasm to develop something, to create something, and just creating an interest to go for the newer technologies, as we are teaching some conventional methods by just saying something to the students and taking a conventional approach to deal with their projects. So these techniques can be used in the future, and as it is in growing field, that's why it created interest, and I have attended all the sessions. Optimization technique also, it may develop some time saving and prompt based solutions. So I think overall FDP was good, and particularly timing. Timing, it is at 2.5 hours. It is not boring, and it takes interest to listen to all the lectures. So I think the timing for the online FDP should be like this, 2.5 hours, not for the full day or 2 sessions. So thanks to the organizing committee of the BIT SINDRI and director sir. Thanks to all.
Thank you, Dr. Giri sir. Thank you very much. Next, please.
Good afternoon to all. Myself Nilesh Ramdas Sonone from Engineering College. Am I audible, Jitendra sir?
Yes. Continue, please.
Yeah, thank you. I am very delightful by attending the FDP, and I have attended almost, as Ajay sir also said, I have attended almost the all sessions, and the various sessions like rapid prototyping, metal matrix composite, their machining processes, then drone technology by Vyom, one of the very good session, then the bond graph theory by Dr. Vivek Kumar and the optimization technique by Dr. Anupama ma'am, and the last session by mechatronics. So all that session, the emerging technology, mechanical engineering of the world, as various previous people said that the timing of the FDP was well managed. So I think this is one of the reasons that we attended to the we have also our personal lecture and all the things that we have attended all the very good timing. And I thanks for that to all organizing committee. Especially my thanks goes to Dr. Kumar, who personally mailed to all the participants and motivated to attend the FDP, and for conducting such a nice session. And once again, I am thanking to BIT SINDRI and the management committee for attending, giving the chance to attend such a session. Thank you.
Oh, thank you, Nilesh Ramdas ji. Now, actually, we are. Hello, Chandan sir.
Yes.
We should proceed for next session.
Yes, sir.
Okay. So, actually, so many participants are interested to give feedback. So, we'll collect from your views and from feedback. Now, I would like to invite Dr. Chandan Kumar, Associate Professor, Department of Mechanical Engineering and Coordinator of the FDP for valedictory note. Now, over to Chandan sir.
Thank you, Jiten sir. Good afternoon, everyone. Respected Dean Academics and Principal Coordinator, Equip 3, Professor Sant Prasad sir, HOD Mechanical, Dr. S.K. Singh, all the deans, heads of the departments, member of advisory committee, faculty members, and dear participants. A warm good afternoon. On behalf of organizing team, myself, Dr. Chandan Kumar, one of the program coordinator and associate professor, Mechanical Engineering Department, Once again, I greet all of you in the valedictory session of 1 week faculty development program on mechanical engineering, emerging technology, MEET 2021. This FDP is outcome of initiative and motivation of our respected director, sir, Dr. D.K. Singh. We have completed it due to the encouragement and free hand given by our respected HOD, sir, Dr. S.K. Singh. I acknowledge and appreciate all the participants for their patience and eagerness to learn. They have attended 6 long day sessions. So I appreciate all of you and thank you. Now I am going to present the glimpse of this FDP. On 24th May 2021, that is day 1, it started with inaugural session. During this session, Professor D.K. Singh, Director BIT SINDRI, delivered a beautiful speech where he mentioned to do the research to make our country as a developed country. He also appreciated the topics chosen for the FDP. In the 2 technical sessions, one on day 1 and another on day 2, Engineer Rajkumar from Adroitic Private Limited delivered an excellent lecture on rapid prototyping and its application. During his lecture, he explained various technology of 3D printing, different types of 3D printers, how CAD is useful for rapid prototyping, how CAD can be implemented for rapid prototyping, importance, principle and application of reverse engineering was also covered by him. Videos included by him in his presentation made this session very interesting. Both the sessions were very informative. On the next day, that is day 3, eminent speaker Professor Dr. S.L. Verma from NIT Greater Noida has presented beautifully fabrication of metal matrix composition and its machining. He explained various techniques of fabrication of MMC. Dr. Verma elaborated the various types of characterization technique, tools, machines required for it. It was a lecture which may be very useful to research scholars. Day 4 witnessed a mesmerizing lecture by very young entrepreneur Vyom Rajan Singh on drone technology. The young engineer is the co-founder of IDR, Indian Defence Reforms. He started with detail of drone and its classification, application. He makes us understand what are the requirements to develop a drone. Vyom detailed each component of drone including sensors, motors, control units and mechanical frame or body. This talk will be helpful to faculty members in their projects whether it is UG or PG. Also, it will contribute in research. On day 5, it was once again a very wonderful talk delivered by Dr. Vivek Kumar, Assistant Professor, Slight Lungua. His topic was bond graph. He introduced this modeling technique in a very simple way. The way of delivery was awesome. At this moment, I would like to remember Professor Vikas Rastogi sir from Professor DTU Delhi, a very learned, cooperative, hardworking and humble teacher. Unfortunately, we could not hear him on bond graph due to his poor health and sudden demise of his mother. But Dr. Vivek taught us very beautifully. I must say he is a worthy student of a worthy teacher. He is a teacher of he is a student of Professor Rastogi. This technique may be exploited by faculty members for research, especially collaborative research, as bond graph can be used for modeling of different mechanical domain like hydraulics, like thermal engineering, design, etc. And today, once again a magnificent lecture on optimization technique delivered by Dr. Nutma, Associate Professor, Galgotia University. She explained the various optimization techniques, their application. During the talk, she made a focus on genetic algorithm. When AI is emerging as a powerful technology, genetic algorithm may augment the research of mechanical engineering also. This talk will helpful in teaching as well as research. And the last but not the least, Dr. Vineet Sekhar, mesmerized by his nice talk on mechatronics. He explained in a simple way this topic. His talk was inclined towards various electrical electronics related components, controls and instrumentation, and their integration for developing a product. We will hear words of wisdom from our guest of honor, Dr. Upendra Prasad Sir, Dean Academics BIT Sindri, as well as Principal Coordinator TQ3 in next couple of minutes. Dear participants, thanks all of you for making this FDP successfully by attending technical session. On the basis of your feedback and suggestions, we will improve the organizing related issue in the next FDP. All the lectures are available on YouTube channels, so you can watch these lectures anytime. At the last, I want to thank all the organizing team members, faculty members of the department, eminent speakers once again. Have a nice day. Thank you. Jai Hind.
Thank you, sir. Now I would like to request Professor Dr. Upendra Prasad sir, Dean Academic and Principal Coordinator TQ3 to say a few words about the FDP. Sir, please.
Thank you, Jitendra. Dr. J. Mato. Good afternoon to all of you. I welcome all the participants and guests on the behalf of BIT Sindri in the validity session of 1 week faculty development program on mechanical engineering emerging technology meet 2020-21. I am happy that the department has organized it in collaboration with TQ3. I would like to congratulate all the participants who have participated this FDP. I hope all of you have gained some new information during this FDP. The topics selected were need of the hour. They were latest and relevant. From few participants, I came to know that the way eminent speakers have delivered talk and knowledge shared by them, like Engineer Rajkumar on rapid prototyping and reverse engineering, Professor Verma on composite materials and its machining, etc. may be applied to do research in the future. Dr. Anupama and Dr. Binit Shekhar, they have also delivered a very good lecture. I am thankful to them. I request all the faculty members who have participated in this FDP kindly share it with your students and colleagues. Whole program was live on YouTube channel. It's a good initiative of the organizing team. I congratulate Dr. S.K. Singh, Professor and Head, Mechanical Engineering Department, and organizing team for organizing such a wonderful program and inviting me in the validity session. Thanks to coordinator of the program, Dr. Chandan Kumar, for taking pain and working hard to make this event successful. I am sure Mechanical Engineering Department will organize similar programs in future also. I assure that department will always receive supports from TQ3 for similar activities. Thank you very much to everyone. Jai Hind.
Thank you, sir. Thank you so much.
Thank you, sir.
Thank you. Welcome. Welcome to all.
Now we'll proceed for the vote of thanks. Before this, I announce that it is our great pleasure that participants from 50 institutions across the country are participated in this FDP during this pandemic. This is a great achievement for us. So now I would like to invite Dr. Dhaneshwar Mato, Associate Professor, Department of Mechanical Engineering, BIT Sindri, and Coordinator of the FDP, to propose a vote of thanks. Ganesh sir.
Thank you, sir. Good afternoon, all of you. Honorable Dr. Upendra Prasad, Dean Academic and Chief Guest, respected Dr. S.K. Singh, HOD Mechanical Engineering Department, our most valued invited guests, ladies and gentlemen. It is my privilege to have been asked to propose a vote of thanks on this occasion. Firstly, I would like to vote of thanks to Director BIT SINDRI Dr. D.K. Singh for attending inaugural function and briefing about FDP program. I thank to Dr. S.K. Singh, HOD Mechanical Department for welcome speech in inaugural function. I must mention our deep sense of appreciation for Speaker Rajkumar, Manager, Atotech Information System Private Limited, Noida, for briefing manufacturing and additives, reverse engineering and 3D printing. Further, I am grateful to Shyamlal Verma, Professor Mechanical Engineering Department, Noida Institute of Technology, for fabrication of metal matrix, composite, and their non-conventional machining. I also wish to express my gratitude to Vam Rajan, co-founder IDR Noida, for deep explaining about the drone technology. I would like to express our sincere thanks to Dr. Vikas Rastogi, Professor DTU, for continuous guidance in whole FDP program. I am also very grateful to Vivek Kumar, Associate Professor, CLET Longwal, Punjab, for briefing bond graph theory. I am very much thankful to Dr. Anupama, Associate Professor, Calcutta University, Noida, for sharing their knowledge on optimization technique and genetic algorithm on this FDP program. I am very much thankful to Dr. Vineet Sekhar, Associate Professor, BIT Sindri, for sharing their idea and knowledge in FDP program about the application of mechatronics in automation industries. I am grateful to Pulkit Srivastava, Assistant Professor, NIT Greater Noida, for extending their technical support. I am very much thankful to all the participants to attend the May 2021. All the participants were very interested. My thanks also go to all people who have given their precious time to organizing May 2021. I would like to acknowledge and thanks organizing committee, technical committee, press and media, without which successful conducting this FDP was not possible. Thank you. Thank you each and every person. Thank you, sir.
Thank you. Thank you, Dhanasar sir. Now I announce for participants, you are mailing your certificates within 10 minutes after the validity section. So you will get through mail certificates. Now that's all from validity session and FDP. Once again, thank you very much, all of you. Thank you. Have a nice day. Goodbye. Chandan sir.
Yeah, thank you everyone, especially the participants who shared their views through feedback as well as online. We will meet it soon in another FDP organized by Department of Mechanical Engineering. I hope in this month only. I request you to support all the participants to support us in future endeavors. Thank you once again. We will meet soon. Thank you.
पापा को मैंने रिमूव कर दिया, छोड़ो ना। हाँ रुको यार, स्टॉप रिकॉर्डिंग।